So we just did step 4A. We created a scratch paper scale for ourselves. So we'll cross that out. Let's try B. B says mark and label your calculated time difference on the scratch paper scale. Okay, so mark and label your calculated time difference on the scratch paper scale. Okay, so calculated time difference. Our time difference that we got, 0 hours, 4 minutes, 30 seconds. Okay, so it's telling us, 4B says, put that calculated time difference on the scratch paper scale. So here's my scratch paper scale. I want to figure out where 4 minutes and 35 seconds is. Okay, so 4 minutes and 35 seconds is going to be roughly halfway. So 4 minutes, 35 seconds. Again, this is the time difference between when that P and the S wave hit. So 4 minutes, 35 seconds, we're going to say it's roughly halfway in between the 4 and the 5, roughly. Again, we're just trying to get an estimate here. Okay. So let's see if we got this. Mark and label your calculated time difference on the scratch paper scale. We did that. C, keeping the scratch paper scale parallel to the y-axis, find the location on the graph where the difference between the P curve and the S curve is equal to the calculated time difference. Whew, it's a huge statement. Okay, let me read that again. C, keeping the scratch paper scale parallel to the y-axis, find the location on the graph where the difference between the P curve and the S curve is equal to the calculated time difference. Okay, so what we're doing here is we're going to try to find on the graph where the difference between the P curve and the S curve is equal to the calculated time difference. This is the tricky part. You have to get this right before we can move on. So what we're going to do is use this like a ruler. Okay, so we're going to use our scratch paper scale like a ruler. You're going to go to your travel time graph. Okay, remember our travel time graph has got two curves on it. We have a P curve, we have an S curve. We want to figure out where the difference between those curves is 4 minutes and 35 seconds. So we're going to use this like a ruler. Okay, so we're going to move this around. We're going to move this around and we're going to try to figure out, well, where is we want the 0 touching the bottom curve. Again, that was that P curve. We want the 4 minutes and 35 seconds touching the top S curve. Okay, so if I pushed it a little ways this way, see how this doesn't work. It's not the right distance. The 0 is touching here, but it's the S curve is touching the 7, so we're too far. If I'm over here, this is too little. So the 0 is touching, but now we're down here at the 2. So you want to find that sweet spot. You want to find out where the distance is the same. So you want the 0 touching the P line, and you want the 4 minutes and 35 second mark touching your S line, okay? And you want to kind of make a mark where that is. So read straight down and make a mark where that is on your paper. Okay, again, this is the tricky part. What you're doing is you're using your scratch paper scale like a ruler. You want the corner 0 mark to be touching the P line. You want that 435 mark to be touching the S line. Once you find that distance, once that distance matches up, you read straight down, okay? So what we just did, okay, keeping the scratch paper scale parallel to the y-axis, find the location on the graph where the difference between the P curve and the S curve is equal to the calculated time difference. We did that. Read down the graph to find the epicenter distance. We did that. Awesome. Okay, so we figured out and I'm gonna push this up here. Here's where our distance was. We read straight down, and so we have a mark right there. Okay, well then we gotta figure out, well, what is this measurement? So for me, it looks like I'm sitting just past the 3 on here. So is this 3.1, 3.5? What kind of number is this? So we know we're above the 3, but we're not to the 4 yet. There's 1, 2, 3, 4, 5 spaces. 1, 2, 3, 4, 5 spaces. So each of these is 2/10. So this, the scale, this would be like 3.2. Let's just count and make sure that these are right. So here's 3.2, 3.4, 3.6, 3.8, 4. So yes, these are 2/10. So, okay, our epicenter distance, we think, is 3.2. All right, but then we got to remember the units. So whatever you get, you need to multiply it times 10 to the third. And 10 to the third is the same as 1,000, okay? So take your 3.2 times 1,000. It's gonna give me 3,200 kilometers, okay? So I just multiplied by 1,000. I moved my decimal over 3 spots. So that is my epicenter distance. So I got 3,200 kilometers. Okay, you should be roughly in this neighborhood. So if you're a bit above or a bit below, you're probably okay, but you should be real close to this 3,200 when you do this. Okay, well, cool. So we're done, right? We found the epicenter distance. Not quite. So we're not there yet. If I told you that you had buried treasure, for example, if buried treasure was 3,200 kilometers away from you, I don't know what direction I'm supposed to go. I know I got a distance, but I don't have a direction. So we're not quite there yet. So step 5, using a compass. On the seismograph station map, draw a circle around the station's location with the radius equal to the epicenter distance. Okay, so this is where we got to look at a map.